We've done law of cosines. Now I want to talk to you about law of sines. First of all, let's recall that we have an area formula for a side angle side triangle that looks like this. Area is equal to 1/2 AB sine of C, or 1/2 BC sine of A, or 1/2 AC sine of B. In other words, I just need to know any two sides and the included angle, and I can find the area. Well, since these are all equal to the area of the triangle, then they're all equal to each other. So I'm going to write them, and I'm going to write them in a certain order with the angles in order alphabetically. 1/2 BC sine of A is equal to, I don't need that, is equal to 1/2 AC sine of B is equal to 1/2 AB sine of C. And now by a particularly clever division, I'm going to turn this into the law of sines. If I divide everything by 1/2 ABC, you'll notice the 1/2s cancel, and also 2 out of the 3 sides will cancel. So the 1/2s cancel, and here the B and the C cancel. Here the 1/2s and the A's and the C's cancel, and here the 1/2s and the A's and the B's cancel. So this leaves me with this very simple expression: sine of A divided by A equals sine of B divided by B equals sine of C divided by C. In other words, if I know an angle and the side opposite and another angle on the side opposite it, the ratio of the sines of those angles and their opposite sides are always equal. So this is another really simple but useful formula for finding missing sides and angles of things. So let's think about when we use law of cosines and when we might want to use law of sines. We use law of cosines in two situations. If we had a side angle side situation where I knew two sides and the included angle, I used it to find the third side. If I knew 3 sides, then I could use it to find an angle. I could use it to find any of the 3 angles in that case. Now, when would I want to use law of sines? That's if I know 2 angles in a side. So if I know an angle in a side, or an angle side angle situation, so 2 angles in a side or an angle with a side in between, then I can use that to find another side of the triangle. So let's look at a couple of examples here. The first example, I have an angle side triangle. In other words, I know 2 angles and then a side. So I have an angle of 30, an angle of 40, and then I have a side of 20 that's opposite the angle 30. So I'm going to try my best to draw this. So there's an angle of 30. So there's my angle A. Then next to that I'm going to have an angle of 40. So I'm going to draw this, try to make it slightly bigger than the 30. So there's 40, that's angle B. And then opposite side, these angle A is side A, which is 20 meters. And then I'm going to go ahead and label the third angle as C, and then label the other 2 sides. Now I want to find side B. So I'm given A and side A and angle B, and then I want to find side B. So I'm going to use the first 2 ratios of the law of sines and set them equal to each other. And we only use 2 at a time. So these are the 2 I'm going to use. Sine of A divided by little side A is equal to sine of B over side B. Now, just to show you, I can also flip them over, and I could write A over sine A is equal to B over sine B. That's equally valid. And in this case, it's kind of helpful to have what I'm solving for in the numerator. It makes the solving simpler. So I'm going to put what I want to solve for in the numerator, which is side B, and then I'm going to say 20 over sine of 30 is equal to B over sine of 40. And then all I have to do is multiply both sides by sine of 40, and I have 20 sine of 40 over sine of 30 is equal to B. Now, in case you didn't think to flip over these expressions, let me show you on the other page another way to do this. So I'm just going to flip over and show another example. So I could have sine of 40 over b is equal to sine of 30 over 20. And I can do what's called cross multiplying. If I were to multiply both sides of the equation by 20, the 20s would cancel out on the right and 20 would end up in the numerator on the left. If I were to multiply both sides of the equation by b, the b's would cancel out on the left and b would be in the numerator on the right. So a simple way to do that is just to say 20 times sine 40 is equal to b times sine of 30. And then just divide both sides by sine of 30. So that gives me b is equal to 20 sine 40 over sine 30. Same thing as I had before. Okay, back to our problem then. Putting this in the calculator, 20 sine 40 over sine 30. Sine 40, and I'm in degrees. Sine 30, and I'm just, 300. And I'm just getting used to doing control enter so that I always get a decimal answer. Then I get 25.7. So let me look and see if that answer looks reasonable. Where am I? Okay. So b is equal to 25.7, and that would be in meters. Okay, that makes sense, because if across from A is 20 meters and B is a bigger angle, then the side B should be bigger than side A. So that looks very reasonable. There's my answer. And of course, side C would be 110 degrees, so side C would be the biggest of all. Okay, given angle PQR, I don't think I once again said what I want to find, but let's find sides Q and R. I want to find the other two sides. So let's go with angle Q is 150. So I'm going to draw kind of a big obtuse angle here. And angle R is 20, so I'll make this one R because that's really tiny looking. So 150. There's Q, there's R, and then this must be P, and side P is 7. Okay, now I want to find sides Q and R, so I could say Q over sine of 150 is equal to, am I going to use P or R? Well, I don't know side R, I know angle R, so not knowing side R, that's not terribly helpful. I know side P, but I don't know angle P, so what am I going to use? Well, actually, hopefully some of you are screaming by now. Yes, we do know angle P, it's just the other two subtracted from 180. Yes, you're right. So if this is 180 minus 150 minus 20, that would end up that P is 10. So I should have drawn that even smaller than I did 20, but I didn't know when I wasn't thinking about that. So I can say then that 7 over sine of 10 degrees is my other ratio. That's P over sine of P. So then to find Q, Q would be 7 sine of 150 divided by sine of 10. And I'll calculate that in a minute. Now let's do the other one. I want to find R. So R over sine of 20. I can use sine of P again. I can use the P angle pair again. 7 over sine of 10. So R is equal to 7 sine of 20 divided by sine of 10. And if I was smart, I would have these all ready for you calculated, but I'm going to pause a moment and I will calculate and you can check back. Okay, and there are my two answers. One of the angles, or one of the sides is 20.15, the others is 13.7. Hopefully you'll recognize that this would be opposite the largest side, or the largest angle, and 13 would be opposite the smallest, or the second smallest angle. This is opposite the 20, this is opposite the 150. So once again, answers must make reasonable sense. Okay, we've got one more problem here, and I just want to show you kind of the setup of this problem. This is a practical application of indirect measurement. Very often in real life, you can't measure directly to something you're trying to find, or it's not convenient or practical to measure directly to something you're trying to find. But you can measure indirectly. So let's say we're standing on the shore and we would like to know how far away from shore this particular boat is. What we can, it's just, running across the water with a jet ski with a tape measure out to the boat is probably not the most practical way to make this measurement. Maybe it is, but that's not what we're going to do. You have to have a long rope. So what we can do is we can measure the distance between 2 points on the shore, A and B. That's pretty easy to do. And we can then look at our angle, stand at the shore looking directly towards the ship from both points A and B, and measure the angle that we are standing in relationship to this distance AB. So we know these two angles and we know this distance. We want to know D. So the question is, can I use these pieces of information to find out what I want to know? So angle A, angle B, and side AB are given. So this looks like an angle-side angle. This is a case where the law of cosines would come in handy. The law of cosines would allow me to find either of these other two sides, whichever one I choose. Once I know this side and an angle, then I can use that same little drop in altitude reasoning that I did with the right triangle to figure out what D is. So think about what you're given, think about what kind of information that is, and decide whether maybe law of sines, law of cosines, right triangles, all of those are techniques you can use now to find pieces of triangles that you're trying to find.